But before that, we have Sam. Sam is a professional software developer, amateur rocket scientist, and astronomer. They love Python, Django, cats, working on their personal software and hardware projects, everything space, playing games of all kinds, and tinkering with 3D printers. Please welcome Sam.
So yeah, this is a bit of a post-mortem, so it's going to be interesting. So yeah, I'm Sam. I'm a freelance software developer and consultant. I've been working on some space robots at a startup and recently started a podcast as well. The rest of the contact info is on the slide, just wasting time so anyone who wants to take a photo of it has a chance, but it'll be there later. So to do a post-mortem of a project, we kind of have to start with what the point of the project was. What was the aim? And in this particular case, it was just a simple project. It was a regular run-of-the-mill business SaaS for a very specific business vertical, nothing complicated, no plans to become a unicorn and change the world and become billionaires, just regular business. And it was going to be done with Ember.js and Django with Django REST framework. Now, for anyone who's not familiar with Ember.js, it has a number of really beneficial features for this kind of plug-and-play functionality in the fact that it actually can base everything off the JSON API. And you can get a nice just plug-and-play kind of functionality from it. And other than just the usual amount of business logic getting put in the back end and the front end where it needed to be, this was just straight up a JavaScript spa and a JSON API backend. Nothing fancy. And that's where you start from your basic concept. Digging in, how are you actually going to put it together? Well, for starting point, there was some third-party app compatibility that was going to be used. We had the Django REST framework. We had Django polymorphism, because when we did the model and schema work, we realized we had some polymorphism that we needed to account for. And there were a few other minor libraries along the way that were all necessary parts of making an entire Django app if you aren't going to sit there and write it all from scratch. Because half the benefit of using a framework is the ecosystem. Now, I mentioned that it's compatibility. Well, that's because a big chunk of this was decided to be built as a reusable app. Now, it does make sense why, but it has consequences. Now, it's a multi-tenant app since it's a SaaS. There are going to be multiple customers. So each one is going to need to have their data kept separate. Now, there's going to be background processing. There's going to be the usual celery for background jobs. There might be some occasional cron jobs. Nothing fancy, just straightforward, good old-fashioned business logic stuff. Now, I mentioned the multi-tenancy, and I mentioned building it as a reusable app. This is what makes the drive on this, because when you dig into the actual process and when the customers' use cases were explained, what we noticed was, okay, there is a overlap between the customers. So some of the customers have multiple locations, and those multiple locations need to have commonality. Things can be moved from one to the other. Some of the things are shared between them, but only some of them have that. So there's a mix between single operators and multiple operators and groups of operators, and it needs to be able to handle all of this in order to be useful for the actual customer base. And that's where it gets complicated, and it becomes a plan to make that tenancy information, that management of the multi-tenancy, into a reusable piece. How hard can it be? And this is the part where I have to put out a caveat. The code you were about to see is old, unmaintained, not free, but it is open source, and feel free to ask a question about that later if you want. And I'm going to do the horrible thing of confronting code that I wrote over half a decade ago. Because nothing is quite so humbling as realizing how stupid you used to be. And I've left it in warts and all. There are to-dos, there are comments, it's got all of it. So we get to the implementation part. We start off with a fairly straightforward reusable app. I'm just going to make a poetry project. Great, off we go. Real easy. Then we get to the basic models after you do your Django scaffolding. Don't think anyone needs to see 8 Django commands at this point. So we've got a tenant model. You can't really track tenancies without having a tenant. It's a straightforward model. We've got a name, we've got an ID, we've got a slug for short URL stuff, and we've got some JSON fields to keep track of various bits of metadata that don't really have a plan yet because, like any business SaaS, requirements may change. You need to be a bit more flexible. And with that, we've then got the relationships. because obviously if we're going to match users to tenancies, we need to actually track that relationship. So there is a tenant relationship piece here, which is using one of the mix-ins you'll see soon, and it's tracking the permissions. So it's got the permissions attached to these objects, and that lets us work out whether someone is allowed to see things inside of a tenancy or not. And then we've got a model manager, because at the heart of this kind of multi-tenancy is keeping track of which kinds of data should come out of the big everything in the same pile schema. Other kinds of multi-tenancy let you just put separate databases and keep things separate that way. That wasn't going to be practical here because of the way things needed to be moved between on a regular basis. So the plan was keep it all in the one schema, and the only way to work with that is to do your SQL queries the right way. So we have our query sets, and in this case, you'll notice that at the top here, it's actually doing a return none. So if we're not actually getting a tenant, it returns none, because it shouldn't actually give information when there's no tenancy there. So the default query path, when this is invoked, will filter for a tenant. And this is what we use inside of the actual base model after we get through the other one, because there's a multi-tenant one as well. And the only difference here is that because there's a many-to-many for these models, the query is slightly different. And when we use them inside the models, it is very much what you'd think. It's just a straightforward abstract-based model mix-in, and it's using the single-tenant model manager there. The multi-tenant one uses the multi-tenant model mix-in. And it obviously has to keep track of the original manager, because every now and then you need your escape hatch. But by default, you want it to be doing things the way you plan on it doing them. And there's a bit of a save logic down there, because obviously you don't want to save something that belongs to a tenant without actually having a tenant to save it to. And that's the difference between these two, actually, because on the multi-tenant one, with a many-to-many, you actually have to save it differently, because it can't exist, it has to exist before you save it to the other object with the many-to-many table. So that's a slight difference between the two. They're otherwise the same, really. Then we have, obviously, because we've made some classes, we're going to have some detail views. We're going to have to expose that data to our front end. Nothing fancy here. I think everyone's seen a detail view before. Now, the middleware is where it starts to get fun, because we're going to actually have to keep track of the tenant as we run through the entire request response cycle. The request has come in for a tenant's data. Which tenant? And do I want to try and modify every single call to pass it down the stack? No. So the only really good place to put that is a thread local, which you'll see in a second. Because when we put it in a thread local, we can actually get that tenant information wherever we need to access it. And using it this way kind of gives us that escape hatch, because we don't want to need lots of extra refactoring every time we change something about this. That straightforward thread local just bypasses the complexity. Although, when came time to actually get it working with async, it became a pain, because this code never worked with async at all. And as mentioned earlier, it needed to support a couple of third-party apps. And then we have the duplicates here. It had to be marked as a duplicate to stop my IDE complaining, because it is functionally just a duplicate. But because of how polymorphic works, you need to actually subclass from its model manager and create basically a duplicate for this kind of work. The way it does polymorphism is its core model manager behaviors, so you kind of have to extend them, and you can't really substitute that and kind of have a universal one. So there's a whole duplicate copy. Also, base model has to be duplicated. And we've got the multi-tenant one as well, and the actual multi-tenant base model. There's a lot of repetition in this kind of code. But as you flesh it out, it does all make a lot of sense. And then we add the Django REST framework support with their permissions framework, serializers for the tenant data so that the front end can actually get that data. It's all very straightforward business stuff. And again, permissions, 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 and another serializer, and another serializer. And we see the permissions are where it really becomes a key thing here, because when you think about the kind of purpose of this functionality is to separate data between customers, naturally you need to make sure that your permissions are structured that way, because obviously the permission to access the data for one tenant is not necessarily going to be completely decoupled from the permission to access the data of another tenant. Because if you're, say, a manager in one office, but you're only allowed access to read data for a different office, that's going to be a different permission structure to, say, being a manager that owns all of them and having full access to everything. So there's a bit of a complex relationship that needs to be handled in these permissions, which is why that's not the whole of it. It's actually this much. So the permissions really kind of give an idea where the real core of this app's purpose is. It is designed to manage and control this. The straightforward business logic of those previous ones really comes down to the nuts and bolts of how do I make sure that I'm handling the customer data the correct way for the users requesting stuff in the app. And consequently, when you actually have all of that noisy code, you kind of want to make your life easier. You have a lot of helpers for this kind of stuff, things like a bypass mode, because if you're running a management command, you don't want all the queries in the entire thing complaining because you didn't give the management command a tenant. You want to just have that code run on everything. Hence, we start making little shortcuts here. There's actually a nice little thing there at the bottom there talking about sentinels. There's actually currently a PEP-in proposal for adding sentinels as a built-in Python language feature. I think they're awesome. It's kind of one of those little things you don't appreciate until you need it. Now, in this particular case, an enum would have done the job, but enums weren't a language feature fully integrated at the time this was actually built. So it's a case where sentinels were the appropriate solution there. Now, it's another talk for someone else to do, but sentinels are quite a nice feature. There are more tenant helpers, things like requesting which tenant came in based on HTTP headers, all the sort of standard SaaS logic stuff. It's, the kind of thing you write lots of these for. But once you're done writing it all, we get to the testing. And this is where the problems begin, because management had a particular philosophy around this choice to make it reusable. It's we'll put it to the side so that we can test it really well. And I'm not kidding. I actually did an entire talk about the stuff I learned to do the testing for this app because it was that extensive. It was very extensive. Cross-database testing. We're running the local tests in SQLite, but is it actually going to work the same when we run it against Postgres? They wanted to make sure, so we kept building tests. I even ended up making a better hypothesis test because, look, .com.net.org is nice, but what if we break parsing on a .nl? Somehow someone manages to mess something up and break the tenant selection logic and trick our system. No, we can't have that. Have to test it properly. Yet more time spent learning how to make this work and actually building this and getting this to actually do its job. And I actually ended up turning it into a pull request and submitted it upstream because it was that much work getting it all to run performantly. And again, yet more time burnt testing. Now, in the end, there is a decent-sized test suite for this, and it does all pass. And it's pretty extensive coverage, too. There's a few places in there where I never could work out how to get it to do those last 1 or 2 lines. But overall, extremely high level of test coverage as mandated by management. And that's kind of where the mistake really lies. Because management wanted to gold plate everything. And gold plating everything is not necessarily a good idea. Now, if you're not familiar with the idea of gold plating something, it's kind of the monster oxygen-free cable kind of a notion. It may serve a purpose, but it's probably pointless. It's a wasteful endeavor. It serves some level of use in the sense that a gold-plated connector will wear out slightly differently and won't oxidize, and it may have a purpose, but you don't gold-plate everything. You gold-plate the things that need to be gold-plated. But the planning led to gold-plating everything. And that's the real context criticality in the middle of all of this. That just like an abandoned subway station here, this was built for a purpose, but that purpose was never realized because the larger context in which it was built wasn't taken into consideration. What ends up happening is that lots and lots of time is sunk building this reusable core logic, testing it to the ends of the earth and back, but the rest of the project moves on, the front end gets developed, and management are looking at a front end that works completely but has no actual data behind it, and the rest of the system hasn't caught up yet because this is still being built and tested, which is very much a case of premature optimization. This was prematurely optimized for a security posture grossly out of proportion for what it was needing to do. And consequently, it fell to this maxim. And this is a pretty common trope. You know, there's a reason that this trope actually goes all the way back to Shakespeare, because there is so many ways that you can trick yourself into thinking that you are on this right path. You will be looking forward, you will project yourself to be a year from now and think, I will need this in a year. It's smart to do it now. But it's not actually smart to do it now if what you're trying to do is something in 2 months. What matters in a year from now is going to be something you should be thinking about 6 months from now, not now. Because if you're literally building from scratch a prototype like this was, going that far down the line is what actually led to this never actually being used and this code being completely wasted. Because the end outcome of this was that it was all thrown in the bin. And consequently, all of the time spent making and testing this, the couple of months solid spent building just this one piece of functionality, and for the most part, the time that was spent building the other functionality around it, all just became pointless. Because at the end of the day, management were unhappy with the performance of a critical part of the app. And this is why it was thrown in the bin, because as the front end was developed, it got to a point where it was fully functional. They were happy with the complete design. And with that design complete, it became time to plug the back end in. And Django REST framework can make this work with Ember.js. It's a model-driven system. You match the models up, and the API just takes it over for you. Not a lot of extra logic required. It's really nice like that. So we get the front end ready. Management are happy playing with it and going like, when's it going to work for real? When's it going to work for real? When's it going to work for real? But it's not going to work for real until we're done doing all this other stuff. And even then, we get to this endpoint where we've managed to do this, we've delivered this, it's taken longer than they think it should have, and then we hit a little bit of a snag, because any kind of quick prototype built this way is going to run into little problems. And one of those little problems was that there was a very important function in the middle of it that involved a very large list. And by default, the way it did that list update was sent one API request for every single item in this list. And some of these lists were hundreds long, which meant that the browser would bottleneck on the round trip because it hit the max queries. And so consequently, it would just sort of sit there and take far too long for management to be happy with. And that became priority number one. And so we dropped everything and started fixing this. Now, at this point, all of the work has been done. The app is functional. The only issue is a single-page performance optimization. But getting it sorted out, making sure that we're doing it the right way, checking that we haven't tripped ourselves up somewhere else, and doing it in a way that doesn't break something else, because any kind of a crash project, you take a few shortcuts and you find that you actually do something later that breaks the thing you did weeks ago. We have that point where it kind of looks like we're doing nothing. And after a little while, after about 2-3 weeks of doing nothing, management are like, this has clearly failed, bin. And the project eventually gets rewritten in a completely different language, another team. That's how business works. But amusingly enough, in this particular case, there was a bit of a salvage job that could be done later, because eventually it came time to do some other project work, and the needs actually lined up quite well with the entire rest of what was built beyond the actual multi-tenancy. So what was able to be done was it was possible to completely rip out the multi-tenancy and just use the skeleton of what was left behind from before to deliver this functionality faster. And in a weird twist of irony, the fact that it was a reusable app made it easier to rip that out and use the rest of the project, because it wasn't embedded into the entirety of the project. So if it had been done the correct way and actually just built as part of the project's logic, instead of in a reusable app, it would have been harder to do that. But overall, the fact that it could be salvaged doesn't actually change the fact that all that time was wasted. And given that this is a pretty broad sort of journey, there's plenty of time for questions for people who want to dive into the specific details of how it unfolded.
Fabulous. I'm happy to run around and get the mic to people who would like to ask a question. Please phrase your question in the form of a question. And here we go.
What language was it rewritten in?
C#.
We have one over here.
Great talk. And what was unique about that management in wanting to gold plate everything?
It was a security concern, and not a completely unreasonable one. Just the mismatch between the technical understanding of the potential risk, because there was a bit of an insurance industry angle on some of this stuff. There was a desire to be up to snuff as far as an insurance company would want to see. So there was a bit of a bias towards needing far more guarantees and security coverage than they really needed in a prototype.
I'm sure somewhere on the project team someone spotted that this was going to be a train wreck early on. What did the project team do to share that message, and why was that message not received?
The project team was 2 people doing 2 different halves. So no one saw it coming.
One here.
I've got to invoke that word. Do you think this is a good argument for agile development?
Honestly, yes. Because it would have been easier to recognize that the mismatch was occurring had there been regular check-ins like that instead of a more overarching project milestone-based approach.
Is everyone okay?
Everyone still has their jobs, and no one's lost any work from it.
That is a great question, particularly in this track.
What would you do differently now? If you had to do it
Well,
again?
I would definitely have incorporated it into the actual project as opposed to a reusable app, because if this had just been part of the project itself, the integration to make it work with all the functionality that was required would have been a much more straightforward process, evolving along with the rest of the functionality, instead of having to be built with all the extra hypotheticals attached to it. Because as a reusable app, there was a lot of sort of reusable app mindset involved. Many of those helpers were only used in the test suite, because when it was built, the thought was, I don't know if I'm going to need this later, but I'm here building this now. I should build this now because it's reusable. I'm going to make sure it just covers all my bases. And that leads to scope creep in that sense.
I think we are also embarking the same journey, you just mentioned, but what do you suggest, how not to fail?
The question of the day. In terms of trying not to fail, the lesson out of this is to be mindful of that context, because the context that it was built in was where the real mismatch occurred. If the context had been appropriate and the goal was to use this in a lot of other applications in a larger organization, this approach may have been perfectly sensible. But that wasn't the context. The context was it was being built for a single specific Django project that was going to be used as a single Django project in a SaaS context. It didn't need this kind of reusable thinking, and that context mismatch is what led to the failure.
We have another one over here.
Presumably there are multi-tenancy libraries already in Django. Did you explore those, or why weren't they up to snuff?
A lot of the existing ones tend to do schema-based isolation or multi-database switching, because those are the kind of easiest ones to share. In particular for this one, this is heavily improved from a very, very minimal prototype I found out there, which is part of the reason why the license is all squirrely. But the core of it being that kind of extra rigor required to do this kind of everything lives in the one schema tends to lead to people not building it as a reusable app, which, back to the last question there, is that if you were doing a project like that, you normally make it part of your project, not built as a reusable piece. So for this specific case, no, actually there wasn't any.
Okay, I'll go here, and then here, and then here.
Thanks. It seems to me the main takeaway of your talk and the project was the bit you covered very briefly about management getting impatient with fixing a problem that took a bit too long. Like, what went on there in terms of communicating, you know, this is fixable, it'll take a bit more time, you know, this is, I don't know, I mean, like all the other stuff is clearly useful, but if that's where the project failed. Well,
You're not wrong. I'm kind of tactically attempting to change the names to protect the innocent, so to speak. But the more broad detail on that is that the time that took from management being happy with the prototype with dummy data to delivery of a real system that they could actually touch and save data to and begin trying to run through the cycles with was about 2 months. So it was about 2 months of them staring at the thing that they were completely happy with, but just had completely fake data in it, and actually being able to use it, during which time visually, for a non-technical management trying to design something based on their understanding of their own business, they sort of perceived a standstill while work was being done behind the scenes. In a sense, this being done front-end design first, back-end plugged in afterwards, while a feature of Ember.js that made that work well kind of also contributes to the management project delivery mismatch that kind of culminated in that final point of, look, we've waited this long, now you've hit another snag. You can only string that along so far before they start to decide, you know what, we're going to cut our losses on this one.
Okay,
Great talk. Do you have any specific suggestions on how to talk to management to avoid a situation like this when you see a context mismatch and they don't, especially if they don't have technical background?
Well, I suppose that's the thing I've kind of taken from this myself, is trying to be more mindful of the context and just to apply that regular sort of talk to management skill set that, you know, I have working as an independent developer. But in this specific case, having not recognized the context mismatch, there wasn't really an opportunity for me to bring that up because I hadn't seen the problem yet. But the regular skill set of, if you do see a problem like that, you should just bring it up to the management, you know, to the best of your ability. It's the soft skills component of learning to work in this kind of an industry. If you have that kind of role where you have an ability to speak to management, that's part of the skill set you need to have to do it.
Okay, I think we had one more question, which is, I think we're going to have to call it there. Here we go.
I don't know, we've got Hiveline over here, but I was thinking along the same path, and I guess sort of management's mentioned a few times. I know there's some developers involved as well, and I guess I was kind of curious about, like, were you in-house developers, were you external? I'm sort of trying to work out the motivations of both sides here. So certainly when, you know, like, was it made clear to management that, you know, this is a front end, there's a lot going in the background, like those kind of project planning aspects as well, which I know I sort of get the feeling everyone in this room is very bright and can develop things, but actually getting people who don't understand what we do on board and making sure that they understand the timelines and where the importance is, and, you know, whether developers at the time, even if we regret it now, was it sort of just in the mindset of just, we're going to make the thing they asked us to, or was it sort of in the mindset of sort of trying to solve their problem, if you get what I mean?
There was a little bit of both. You know, I was the senior developer on this one. There was an in-house junior. In that particular situation, I was being brought in as more experienced to sort of steer things and do other work for other projects they had going. The overall cycle was actually kind of broken in those two halves. There was the development of the front end, discovering the user's needs and actually actively communicating with them to try and find out what they wanted and to build the best app possible for the job they needed it done. But where the mismatch came in and sort of what that, you know, I think you're getting at there is that there was that mismatch in terms of whether or not it was fully understood by them, what was going on in the second half. And while that was outlined as part of the planning, the amount of time that passed in between those two steps may have led to some sort of a misconception creeping in that wasn't identified until at the end of the actual outcome, they decided that their perception had shifted significantly from what it was originally in that very interactive phase for them. And that's sort of more of a social capital kind of a problem in terms of trust in the actual relationship. You deliver it very, very quickly, trust builds, they start to see that things aren't being delivered at the same rate. There's going to be a gradual erosion of the trust in terms of that management communication flow. And you have to be mindful of that in terms of that communication pathway and making sure that they are actually on board and do understand. But once there starts to be that sort of misconception and that slow, gradual loss of the social capital, they will begin to question whether or not you're actually giving them and feeding them a line, and you don't really have the thing. And at that point, it's all going to fall apart anyway.
Alrighty, that was quite a story. Very interesting, thank you. We have a special gift for